Hello, welcome to Drafting and Design Center. Today we're gonna have a discussion on how to use feature lines for estimation of earthwork for RCC footing using Civil 3D. So this is a topic I have chosen it just to demonstrate how we can use feature line to be able to estimate quantity of earthwork for construction of footing. As you can see on the screen, there is a site uh, that has survey, and it is surrounded near the bitumen road, few tanks near the lighting equipments, electrical meter is there further north side, which is not on the screen. uh, and intention is just, as you can see here, I have already graded this site. This is the footing, which is about 50 square meter. So intention is to create a earthwork volume for this 50 square meter of footing, and the lines you can see surrounded, these are the feature line. This feature line footing floor surface elevation is being graded out in a Civil 3D. So for that we need to consider, before we get to the earthwork stage, earthwork quantity calculation for footing, construction of footing, we need to consider few of the factors which are given here. That is location, drainage. Location means exactly how it's gonna fit it with a construction of footing, toilet, and then the path which allows people to walk from road towards toilet, how that's gonna fit in all together. Drainage consideration, uh, as you can see, there is still a big 2000 20,000 liter of tank was there, further waste side. So once toilet will be there constructed, how we gonna discharge stormwater? Are we gonna put a put a put a pit and then connect down pipe into the pit, and from that pit PVC pipe into the cup using cup inlet connector. So these are the consideration we need to give. Sewer is the main consideration. Sometimes the site is located where it is off the road, there isn't much more sewer connection facility available. If that is the case, how we gonna get the sewer out using detention facility, and how we gonna pump out an effluent system, how we gonna design it. Utility, sometimes utility is passing for chosen site, chosen area. For example, it could be a PE pipe, HDPE pipe that supplies water to the surrounding, as you seen on a screen earlier. Could be supplying the water to tennis court, maybe play field which is located nearby. Lighting, how we're gonna connect electricity from the meter into that toilet block. Type of construction, are we gonna have, either we're gonna use the steel embedded into the concrete, or it could have been H beam that will facilitate the construction of block works. And then blockworks supports roof, timber rafter, and then colorborn roofing system. Or either it could be a completely precast concrete wall, and then assembling up the side and putting back into the side. So these are the construction method. Either is gonna be steel beam, steel column, either it's gonna be a edge footing and block works, or are they gonna be precast construction? Type of footing, again, it is based on a edge beam type, or it could have been waffle slab that supports precast wall that joins into the waffle slab using dowel and shear connector. So those are the type of the footing, and obviously type of soil, class of soil, whether it is structure, fill, and bearing capacity. However, in this short discussion, I have not included all the factors in detail. I have provided that, and based on above, this is the site. As you can see that we have selected here uh, the 50 square meter of footing area, and as you can see the finished floor surface, I have provided elevation using the feature line 613 is there. So all the station from this station to this station, this, which is you can see on a screen my cursor, and here all has an elevation of 613 meter. And once feature lines, you can have polyline, 3D polyline. You draw 3D polyline using a feature line. You can convert in a feature line and then provide the elevations. That is based on the factor which I defined earlier. For this one, I have provided 613 is elevation. You can see here on a snapshot. Once elevation is there, basically for 613 is a finished floor surface. Our footing shall be about uh, shall be about shall be about 600 to 400 millimeter above that. So 613, as you can see here, that represents below footing. The footing FFS shall be above that. So the intention here is going down the footing and creating a earthwork which can help to construct the footing. So now we gone. So from 613 here is elevation. My finished floor surface will be 613.5 above this elevation. As you can see here, I have used a grading tool, and once you have grading tool in civil theory, you can define a grading style. As you can see on my cursor, first you have to define uh, grading grading type, and then as you can see on a cursor, surface, which surface grading drafts to, and then which kind of grading we want. So I have defined the grading type as a T, and then inside that I have set up the criteria of cut slope, which is 4 in 1, fill slope 4 in 1. So once you define that, feature lines and grading style, basically you have to select the feature lines and grade all the way. It itself done by that way. So once I have defined the grading, which is here is a feature line 613, I have then gone into the grading tool and created grading all the side, which is 4 in 1, 4 in 1. So this is the earthwork we require to do prior to construction of footing. 4 in 1 is a preferred slope in terms of soil stability. Again, it depends upon other criteria too. However, it was structure field on our site. We decided to go 4 in 1 slope in here. So this is the bottom of the footing, and then this is a bit of a cut, and this is a bit of fill, and this is a bit of a cut in here. So the same procedure is here. Once footing is being graded, bottom of the footing is being graded, you can use surface and create a surface from that. So this is the surface of the earthwork, and including bottom and then excavation part. Once surface is there, you can compare that surface, which is a footing surface I created earlier, with a natural surface. it will then give you a volume surface, and then you can see that I have created a new surface. It compares base surface as a natural surface, the one is been surveyed, and the one we created for 4-in-1 slope, defining 4-in-1 slope, I have named as a footing. And this is a comparison of cut volume and fill volume. Once again, thank you very much for watching. Please subscribe our channel if you like to uh, view similar kind of short discussion tutorial. uh, I hope you enjoy watching. Once again, it was more about application of Civil 3D to estimate cut and fill volume. uh, Thanks very much.